Hello, everyone. This set of notes is going to be on 2.3 and 2.4. So, sources of biodiversity, mainly looking at island biogeography as well as ecological tolerance. Here we go. So, first, a couple of things to review. Obviously, it's a little hard to do this in Edpuzzle because I can't have you draw, but it's okay. I want you to think of these two things in your mind. So one, using a diagram to show how natural selection leads to the generation of new species. And two, draw and label a range of tolerance curve. So this is something that take a minute, pause the video right now, try to either draw these if you have something, or think about what these would look like from biology. So hopefully you actually did pause it because, hey, take advantage of this. It's just not, hey, can I get this as fast as possible? Remember, these are your notes. So with natural selection leading to those new generations, so over time, I use this little snail picture here. You're going to have some kind of variation in the species that you have, and it's something that could either be a disadvantage or an advantage. So in this one, we have a snail with a darker colored shell. Over time, that darker colored shell is more suited for its environment, so you see more of that gene being expressed, and eventually it gets to such a level that you have a new generation that is its own species separate from the light colored shell. So something was advantageous about it and made it be its own species down the road. For our tolerance curves, so our tolerance curves are going to tell us where a species can live and what things they can tolerate. So this can be for temperature, pH. Those are two big ones that tend to be used, and that's the ones that I can think of because obviously they're on this graph here. But in the middle of this bell curve, so it's always going to look like a bell curve, the middle is going to be its optimal range. So in this, we'll say it's the optimal temperature that they can live at. Towards the edges, you're still going to have some individuals of that species live there, just not as nearly as many as you have here. And this is where they're going to start to feel stressed, so it's harder to live there. Anything outside of that range, they can't live there. It's either too hot or too cold. So essential knowledge stuff. So one, ecological tolerance, and just referring to the range of conditions, so temperature, salinity, flow rate, sunlight, etc., that an organism can endure before injury or death results. Ecological tolerance applies to both individuals and species, so we're looking at both. With island biogeography, this is the study of the ecological relationship and distribution of organisms on islands, both literal and metaphorically, and of these organisms, community structure, so how their community is actually in place. And these islands have been colonized in the past by new species arriving from elsewhere. Another one is many island species have evolved to be specialists versus generalists. So they're going to focus in on one thing on that island, and if that one thing is gone, that's going to put them at jeopardy. We don't want like a new species to come around and outcompete them. So range of tolerance and biodiversity generation. So range of tolerance and biodiversity kind of go hand in hand. It's kind of a cyclical loop. So if you have a change in your range of tolerance, or ROT, eventually that is going to lead to speciation. So some new species is going to arise because of essentially this pressure from the environment. And since the speciation arises, you're going to get a rise in biodiversity. New species is going to add, obviously, more biodiversity to an area. That's going to increase the competition. More species, more competition. And that can increase resources because it can cause species to become, like it said in the other one, more of a specialist species. And then that's going to lead to even more natural selection. And then you can see a change in the range of tolerance. So it's a cyclical thing that can just keep on going and going and going over and over and over. So one thing with range of tolerance and the edge effect. So the edge effect happens when, from the fact that not all of that area or habitat is identical. It's not the same. There's differences that are speckled throughout it. And I don't have something like that, but say that we have a field and there's something like a road gets built through the middle. Well, obviously, that area and that habitat is not identical to the rest of the field. So you're not going to see as many individuals in that area that you would see somewhere else. It's still going to kind of cause that area to fragment, but we can talk about that later. It can also lead to more or less biodiversity. So say that for some reason, pressures cause two species to overlap their range of tolerance. So the range of tolerance down here for the red and green, and it's just some made up thing, but cause them to overlap. And in the middle, right here, you're going to have a really high biodiversity because of the melding of those two species. And that could be in an area where, say that it's in the mountains and for some reason there's a stream down below. So maybe it's moisture that we're looking at as the range of tolerance. And as you get closer and closer to the river, you're going to have a higher and higher biodiversity because you have species intermingling. So now, time to put some of this to work. Using your noggin and the concept of the edge effect, explain why the boundary water canoe area strictly forbids any and all wheels, including small canoe carts, within the park. So think back to the last slide of why might this be a thing, especially in terms of biodiversity. I'll give you a second. So island biogeography. So one thing with our biodiversity is it's always going to be a function of both habitat size and distance from the mainland. This is where the island part of it comes into play. So there's this graphic right here. So the closer that something is to mainland, if we have a larger island, we're going to get many species because they're nearby. It's easy to get to. So think about like a bird flying. It's way easier to fly to a large island, that's close, than a small island that's close to the mainland because it's just a bigger area to land. And vice versa, if you have something that's far away, if you have a small island, it's even harder to land on. It's kind of like trying to thread a needle from really, really far away. So you're not going to have as many species make it there. So then your species richness is going to be lower. But if you have something that's far away from the island, mainland, and large, you're still going to get a fair amount of species because it's just a bigger target to hit. It's easier to hit than our small islands. And this can be, like it said, figuratively with those islands, or it can just be because, like metaphorically, because of different areas and range of tolerance for this island biogeography. So remember that can also be the case. So another one, try to use your noggins here. Use the concept of island biogeography to write a strategy statement for an organization with limited funds that wants to maximize its effectiveness when restoring native prairies. So this one's a little bit more difficult, but what would your statement be? How would you do this with that limited amount of funds? Give me another second. All right, and to leave you, I don't know why I said lead. I have another one for you to give a try to with island biogeography and range of tolerance. So imagine you have two species that occupy the same trophic level, are roughly the same size, and exist in roughly the same climate. Species A lives in a moderately sized island or on a moderately sized island far from shore, and species B lives on the mainland. What would a generic range of tolerance curve for each species look like? Go ahead and give that a try. So with that range of tolerance, with the curves that you made, hopefully you could say, okay, well, if it's the same trophic level, they're same size, and roughly the same climate, well, maybe you can really keen on the climate and say, well, their range of tolerance would be mostly the same because of all these similarities. It doesn't really matter that species B is on the mainland and species A is on a moderately sized island. Something like climate, if they're the same, their range of tolerances could look the same theoretically. But that does it for this set of notes. Thank you. Have a good rest of your day.